Hi, I'm going to speak about deep learning based object detection. So, nowadays, object detection has become more popular as it is used in various applications like face detection, security, autonomous driving, and so on. So, now we are going to talk about some representative object detection architectures. So, generally speaking, it has like two types of object detectors, two stage detectors and one stage detectors. So coming to two-stage detectors, here we have faster RCNN, RCNN, master CNN, and so on. So they use a regional proposal network to generate regions of interest in the first stage, and then send the region proposals uh, down the pipeline for object classification and bounding box regression. So these types of models have the high accuracy rates, but typically slower. So, coming to one stage detectors, they have YOLO, SSD, RetinaNet, and so on. So, they treat object detection as a simple regression problem by taking an input image and then learning the class probabilities and also the bounding box coordinates. Also, such models reach lower accuracy rates but are much faster than the two stage detectors. So here two stage detectors are CNN. Um, so it is generally a region based CNN detector which is used for object detection. It has like four modules, uh, which are category independent region proposals. Second module is like fixed length feature vector from each region proposal. The third module is a set of class specific linear support vector machines to classify the objects in one image. So the last module consists of the bounding box regressor for precisely bounding box prediction. So fast RCNN, and here we have a comparison of RCNN, fast RCNN, and also faster RCNN. So both of the algorithms RCNN and fast RCNN use selective search to find out the region proposals. So selective search is a slow and time consuming process, so which affect the performance of the network. So to avoid this, we use faster RCNN. So where we have a separate network to predict the region proposals. The predicted region proposals are then reshaped using ROI pooling layer, and in further steps it is used to classify the image within the proposal region and predict the offset values for the bounding boxes. So here we can see the mean average precision is common, similar for all the CNNs. So but the computational time is increasing compared to RCNN, fast RCNN, and faster RCNN. So and also the test time per image is very less in faster RCNN. So coming to one stage detectors, we have YOLOs, SSD, and so on. So all the previous object detection algorithms we talked in two stage detectors, they use region to localize the object within the image. So the network does not look at the complete image. They only look at the parts of the image which have high probabilities of containing the object. So here in YOLO, it is an object detection algorithm. So it is much different from the two-stage detector algorithms. So in YOLO, a single convolutional neural network predicts the bounding boxes and the class probabilities for these boxes. So it takes an image and split into S by S grid. Within each of the grid, we take m bounding boxes. So for each bounding boxes, the network outputs a class probability above a threshold value and is selected and is used to localize the object within the image. So but the main limitation of YOLO is that it struggles with the small objects within the image. So, for example, it cannot detect if there is a small object like a bird very distant in the image. So for further improvements, we have used SSDs and DSSDs and so on. Here it's an improvised version of YOLO. I mean the previous next versions, further versions. So coming to data sets, using challenging data sets as a benchmark is significant in many areas of research. So because they are able to draw a standard comparison between different algorithms and set goals for solutions. So here general object detections, um, we use Pascal VOC dataset and MS Coco benchmark and ImageNet benchmark and Open Images V5. So here examples of sample images from that dataset have been also produced. MS Coco benchmark, it's a Microsoft Common Objects in Context dataset. So it has like 91 object categories, with 82 of them having the 5000 label instances. So some of them are like iconic object images, scene images, and non-iconic images. And Now coming to the analysis of general object detection methods. So generally speaking, deep neural network based object detection pipelines have four steps in general, like image pre-processing, feature extraction, classification, localization, and post processing. So these are the common steps followed in analysis of general object detection methods, like training from scratch, speeding up detection, and achieving fast and accurate detections. Uh, Coming to applications, object detection is used in many fields for various purposes. Uh, Without knowingly, also we have many applications which we use. Like for example, in security field, we use it for face detection. So it aims at detecting people's faces in an image. So because of extreme poses, resolution variations, face detection is still a difficult mission, so which can be solved by using different methods which we spoke about recently. I mean, like two stage detectors, one stage detectors, and so on. And also in transportation field, we use it for license plate recognition and autonomous driving. So conclusion. So object detection is growing rapidly in different fields with the powerful computational equipment. We are achieving a high accuracy and also efficiency. So yes, although it is effective, there is still much room for further development. We can do and try to improve it in many ways. Here is the article link where you can get more insights of this about this uh, presentation which I gave. Thank you.